Hey guys, welcome back. Hope you guys are doing well. Today let's see an interesting problem from problem of the day Geeks for Geeks, which is cousins of a given node. So the question says that given a binary tree and a node, print all cousins of a given node in order of their appearance. Note that siblings should not be printed. Okay. So basically they are going to give us a binary tree and a node. We have to print all the cousins of the given node except its sibling, right? So that's what the question says. And also question says that if there is no cousin in the given node, we just simply have to return -1. Okay, let's understand this question more clearly with an example. So let's take this first example, and the given node is 5. We have to print all the cousins of the given node 5, right? So how can we do that? As you know, 5 is present here and its sibling is 4. So we have to print all the cousins. Here the cousins is nothing but all the nodes which are present on the same level of the given node, right? So all the nodes which are present on the same level are 4 and 5, and we have to exclude its sibling and the node itself. But the sibling is 4 and the node is 5, because this is not the cousin to itself, right? So the remaining elements are 6 and 7. These are the cousins on the same level except its sibling, and the answer is 6, 7. So I hope you guys understood the question. So let's see how to approach this problem. So in order to find all the cousins, here cousins are nothing but all the nodes which are on the same level. First we have to find its level, right? We have to find the level of the given node. Then only we are going to get all those cousins. So how can we find the level? So as you know, we can do this using DFS. So basically what we will do, we are going to divide this problem into two sections, where the two subproblems, where the first problem is to get the level of the given node. So the first one is get the level of the given node. So this is the first subproblem, and the second subproblem is, after getting the level of the node, we have to get all the nodes which are present on the same level. For this, as you know, we can use BFS, right? So the second subproblem is get all the nodes on the same level except its sibling. And the node itself, right? Except the node itself and its sibling, we have to print all its cousins. So how can you find the level? So how can we solve this first problem? We can use DFS, right? And in order to find all the elements which are on the same level, we can use BFS. So here we are going to use these two algorithms, which are DFS and BFS, to solve this problem. Okay, let's see the first subpart, which is to get the level of the given node. And also we know that in order to print all the elements on the same level, the first thing we have to find is the level, and the second thing is its sibling, right? Because once we get the level, we can get all the elements on the same level, but we have to exclude its siblings too, right? So for that purpose, I need two values, which is the level and its sibling, so that I can print all the elements on the same level excluding the sibling. I hope you are getting. So for this purpose, I want this DFS in such a way that it should return me two values. The first one is the level of the node, and the second one is its sibling. So for that purpose, I will consider a pair. So just give me a minute. I will consider a pair. So where the first value represents its level and the second value represents the sibling of the given node. Okay, I hope you are getting. Okay, let's see how can we do that. So first I will initialize both values as -1. Okay, so yeah, the nodes ranges from 1 to 10 for 5. So we can take it as both values is level as -1 and its siblings are -1. I will initialize both of them as -1 and make a DFS call. This can be moved here, and we cannot found it, and here we cannot found, and return back and move here. Yes, we have found the value here as 5. So what is the level? So level of this node is 2. So we can find that simply by calling each DFS by incrementing its level as 1. So at first it is 0, and while calling DFS we have to increment its level as 1, and here it is 2. So what I will do, I will I will update the first value as 2, which is level, and of course the second one is sibling, and we are not found its sibling, so I will keep it as it is as -1 and return this value. And now the only thing we have to find is its sibling, right? So how can you find that sibling? So this is easy. See, observe carefully. Whenever we return some value, so whenever we return a pair, so if the first value is not -1, so this first value represents level, right? So if it is not -1, that means we have already found the node. So we have found the node, and the other thing we have to do is to find its sibling, right? So how can we find its sibling? As you observe here carefully, so if this is the node that they have given, and what is its sibling? Its sibling is nothing but the other child of its parent, which is 4, right? So what we are gonna do, so whenever we find that the node is found and the level is updated, so all we have to do is whether its child is equal to the given node or not. If it's one of its child is equal to the given node, then its other child is nothing but its sibling, right? I hope you are getting. So in this way we are going to find the second value, which is its sibling. So, and then after use this BFS and find all the nodes in the given level except its sibling and the node. Okay, I hope you are getting. So let's jump into the code. Okay, first I have to initialize this pair, right? So I will initialize its level and its sibling as -1, which I will say result is equal to some make pair of -1 comma -1. So, and now what? I have to make a DFS call in order to update them, right? If DFS of, so yeah, actually we don't need this because DFS is going to return them anyway. So DFS of root, and we have to find the target node, and its the current level is 0. So DFS has to return me 2 values. We'll consider this as target and it is level. So I will carry on only if the current root is not null, or else I will just simply return -1 comma -1. I hope you are getting. So now what? All we have to do is, first thing we have to do is check if the current root is equal to the target one or not. The current node is equal to the target node. Then I just simply return pair of, I have to update its level, right? So its level will be the current level, and its sibling is not yet 4, so I will just simply make it as -1. Or else, so the current node is not equal to the given node, I have to make left and right call, right, in order to find its level and node sibling. So for that, let's take like left or some result is equal to DFS of left target, and have to increment this level, right? And if in order to check if the node is found or not, I have to go with the first node, which is level. If result dot first not equal to -1, it means I have already found the node. All I need to do is to find its sibling. So I can only do that if its left child is equal to the given node, so its sibling is nothing but its right child. So first I will check if root dot left dot data is equal to the target dot data. That means its left child is nothing but the node they have given. And what is sibling? Its sibling is nothing but the right child. So in order to do that, first its right child should not be null, right? If it is not equal to null, then its sibling, which is second, will be root dot right dot data. I hope you are getting. And then I finally return the result. So what if I have not found any node towards its left side, I have to make DFS call towards its right side. Right target, and I have to do the same thing as we done above. If it is updated, and if its right child is nothing but the given node, its sibling is nothing but its left child. For that, its left child should not be null. So if it is not null, then it is going to be its sibling, and we have to update its value. And I'm finally going to return this result. So what if I have not found, in both the cases I have not found its node towards its left and right child? This is going to come out of this, and it is going to return -1, -1 anyway. I hope you understood this DFS call. And now what? So first we have to check whether we have found the node or not. Okay, so for that, if result dot first which is the level, if it is equal to -1, that means we have not found the node yet. So I'm gonna simply return like -1. Okay, otherwise we have found the value, and all we have to do is use a DFS to find all its cousins. For that, I will take as answer, and for DFS anyway we are going to use queue, right? So I will store all nodes inside this queue, and initially my queue will be equal to root, and I'm gonna also push null. This represents the end of the first level or end of a particular level. How many levels we have to iterate? This is equal to the result dot first value, which is equal to the level of the given node. So I have to find these levels, all the nodes, until I have to reach until to the level of the given node, right? So at each time I'm gonna push all the elements at a particular level, like q.front not equal to null. So this means we have not completed the current level yet. So take this t q.front, or else I will consider it as current level q.front, and I have to pop it. Now I have to push all the children of the current node into the queue. If not gonna null, so I have to push it right. Current node but left. Similarly, I'm gonna push its right child if it is not null. Okay, and after all, so this condition will become false. That means we have completed a particular level. So all I have to do is remove that null, and again I am going to insert null at the back of the queue. That means this is the end of the current level. So whenever this for loop will complete whenever we reach a particular level which is equal to the level of the given node, and we will come out of the loop. And now all we have to do is while q.front, we have to iterate all the elements inside the queue until we reach the end of the queue, and let's consider it as current node. So q.pop, and I have to consider it into my answer only if it is not equal to its sibling and it is not equal to the current node. That means if current node data not equal to the node to find data, and current node data should not be equal to the its sibling. Where it is sibling is located is in result.second. Then only I will push it into my answer. I hope you are getting. current node dot data, and that's it. And finally, and one more thing, we have to check like if there are no cousin, what does this mean? So there are no cousins means our answer is gonna empty, right? So if answer dot size is gonna empty, that means no cousins found. I have to insert -1. This is what they mean, right? So and finally I'm going to return answer. Let's compile this. So we got an error, return make pair of double comma -1. Okay, where the line number is 127. Return make pair of, oh sorry, is a function, right? Let's run this. And yeah, we found it. Let's submit this. And yeah guys, we have successfully solved the problem and hope you guys are enjoyed it. So and see you in next session.